Hello guys, let's prove this limit identity over here, and we're going to be using three ways to solve or prove this limit over here. So let's begin with the conventional method. For this method, you're going to have to convert e to the power x into some form of log or log natural, because here with e to the power x you can't really do much with it, but there are some properties with the log that we can use to prove this limit over here, and that one property is the power property. So ln of x to the power n, well, this power simply comes down and becomes n ln x. But the interesting thing over here is we're not going to be using this property to get this. We're actually going to be using this property to get this, meaning we'll put the power back inside. So let me show you how that can be done. First, let's let u is equals to e to the power x minus 1, and here we need to find x. So we have e to the power x equals to u plus 1, and simply log natural both sides. When you do that, the ln and e will cancel and the power will come down. So this is ln 1 plus u, and put that in there. But before that, you see we have x approaches 0, but we have changed the variable into u, so we need to find to which number u approaches to. So when x approaches to 0, so this is 0, you'll have 1 minus 1, so 0, which means that u also approaches to 0. So we have u approaching or limit 0, this is just u, and this is ln 1 plus u. Now we're going to have to do something a bit crazy. We're going to have to use a bit of algebra, a basic algebra. So if you have a by b and you want to kind of make it into b by a, so it's like this. But here you change the value of this fraction. They are of course not equal to each other, but it is equal when it is whole divided by 1. Because if you multiply a on numerator and denominator, you'll get this over here. And we're going to have to use this fact over here. So this is u approaching 0, 1 by ln 1 plus u by u. And if you watched my previous video, we have done this limit identity over here, but I'm going to do it again. So this ln 1 plus u by u, we have to use this property over here, right? Well, instead of this by u, I'm going to write it as 1 by u into ln 1 plus u. And then we're going to put 1 by u inside of the power. So this becomes ln of 1 plus u whole to the power 1 by u. And we're going to have to use a kind of limit property such that we can put the limit inside of the log function. So this is log u limit 0, 1 plus u to the power 1 by u. And here, this is a kind of a famous limit. This limit over here actually is just e. Now, you may have seen the definition as n approaches infinity, 1 plus 1 by n to the power n. But if you just switch the fraction around, let you know m equals to 1 by n, the m will approach to 0, this will be 1 plus m to the power 1 by m. So basically it will be like this, but since m is just a dummy variable, it doesn't matter. Any number m, a, b, c, d doesn't matter, this will all be e. So that means this and this are the same, meaning we have 1 by ln of e, which is just 1 by 1, which is 1. That is our conventional method. Now let's go on to the expansional method. So, as the name suggests, expansional method, we have to expand something. And here it's obvious, we have to expand e to the power x. So let me just show you what the expansion is. So I'll just show you for e because it is quite interesting. It is 1, plus 1 by 1 factorial, or this one is actually starts from 0 factorial, plus 1 by 2 factorial, plus 1 by 3 factorial, and so on. But if you have e to raise to some power, it actually becomes here x to the power 0 by 0 factorial plus x to the power 1 by 1 factorial plus x to the power 2 by 2 factorial, and so on. So we're going to have to use this over here. So e to the power x is all of this over here. So x to the power 0, which is actually just 1. 1 by 0 factorial plus x by 1 factorial plus x square by 2 factorial, x cubed by 3 factorial, and so on, whole divided by x, all minus 1, and then you can simplify it. So here 1 by 0 factorial is just 1, you can cancel this over here, and you'll end up with this, and simply divide each of the term by x. So that means from each of the term, 1 power of x will be cut off. So you'll have 1 plus x by 2 factorial plus x square by 3 factorial plus x cubed by 4 factorial, and so on. And now simply put the limit in. This will be 0, this will be 0, and all of the terms after it will all be 0, and in the end you'll just have 1. This is the expansional method. Now let's go to the unreasonable method. For the unreasonable method, which actually should be unreasonable method, but I wanted to make it rhyme in the thumbnail, so just that, we're going to have to use an L'Hospital's rule, which briefly is, if x approaches a, f of x by g of x in the form of 0 by 0 or infinity by infinity indeterminate form, then this limit is equals to, as x approaches to a number a, f derivative of x by g derivative of x, as long as the derivative of gx or g of x is unequal to 0. And here, this is the unreasonable or unreasonable method, because here, as you can see in this limit, we're using derivatives over here. But this is a limit identity, and derivatives in itself comes from the first order principle, which is just limits. So you're using derivatives to prove a limit, while the derivative is in itself is a limit itself. So this method is known as circular reasoning, which is an illogical proof or unreasonable proof. But anyways, let's apply it. This is in fact 0 by 0. Plug it in, you'll have 1 minus 1 by 0, which is 0 by 0. So just take the derivative, x approaches 0, e to the power x by 1, and just put the limit in, e to the power 0 is 1, and boom, 2-line answer. But it's unreasonable at the end. However, if you want to just do math for fun, you can try this as well as the conventional way or the expansional way or any way you want. And if you learn something new, please like and subscribe. Thank you.